today we are going to be looking at the Pythagorean Theorem. So the Pythagorean Theorem in a right triangle is the sum of the squares of the legs, and that is equal to the square of the leg of the hypotenuse. So if we have a right triangle, the two sides, so shown here A and B, that are connected to our right angle, we call those the legs. And then the side that is across from the 90-degree angle, or the side that creates a diagonal, that is your hypotenuse. So what this is saying for the Pythagorean theorem, we call our legs A and B, and our hypotenuse C, we have A squared plus B squared, and that is going to equal our hypotenuse, which is our C squared. So this is our formula that we are going to be using. So let's look at some examples. We have a right triangle here. We have a side of 6, a side of 4, and both of those are our legs, and we need to find x, which is our hypotenuse. So write out the formula: a squared plus b squared equals c squared, and substitute in a and b and x for c. So we're going to have 6 squared plus 4 squared. That's going to equal our c squared. So now we're going to calculate. We have 6 squared, which is 36. 4 squared is 16. Don't be afraid to use your calculator. And that's going to equal our c squared. Now add it. 36 plus 16 gives us 52. So 52 is equal to our hypotenuse squared. So we need to undo squaring. So some of you might know what to do, some of you might not. So to undo a square, we are going to take the square root. So we take the square root of both sides. So that cancels out. So we are only left with c equaling. Now in our calculator, we are going to do the square root of 52. So you're going to hit second on your calculator, and then you're going to hit the x squared button, and then type in 52. And that is going to give you 7.21110 continuing on. So we can just round it to 7.2. So let's add a note. So in calculator, you're going to hit second, and then the x square button. And that's going to give you the square root option. Okay, let's look at the next problem here. We have a leg of 15, a leg of 9, and then a missing value. The missing value here is our hypotenuse, so that's going to be our c that we are solving. So write your formula: a squared plus b squared equals c squared. Substitute in 15 squared plus 9 squared equals c squared. So now we are going to simplify. 15 squared is 225 plus 9 squared is 81. And bring down your c squared. Now we're going to add 225 plus 81. That gives us 306. And that's equals c squared. We're not done. We have to get rid of the square. So take the square root of both sides. So in your calculator, calculate the square root of 306. So we get in our calculator 17.4928. We want to round, and this continues on. So we want to round to the tenths place. We look behind it for the 9. 9 we are rounding up. So we get 17.5 to be our C length, our hypotenuse length. Okay, let's continue on. The third one here, I want you to try this one by yourself, then come back and check your work once you are done. Okay, let's check our work. So we have two side lengths of 8 and 4, and then our hypotenuse is unknown, so we need to find that value. So let's use Pythagorean Theorem, a squared plus b squared equaling c squared. Substitute in 8 squared plus 4 squared equals c squared. 8 squared is 64. We're adding it to 4 squared, which is 16. So 64 plus 16 gives us 80. And then we are going to take the square root of both sides. So the square root of 80 is equal to 8.9. That is rounded. Okay, let's look at this last problem. So we are given a leg, which is 12, and the hypotenuse of 15. So we need to find the missing side length here. So we're just going to name that A. It could be B. It doesn't matter which one for your legs. So let's use the Pythagorean Theorem. We don't know A, but we know B is 12 and C is 15. So let's solve this. 12 squared is 144. Bring down your A squared. That's going to equal 15 squared, which is 225. We need to solve for A squared. So we need to subtract 144 from both sides. Cancels out. So we have A squared equaling 225 minus 144 gives us 81. Now we're going to take the square root to cancel out the square on both sides. So we're going to get A to equal the square root of 81 is 9. So that missing side length is equal to 9. Okay, let's take this a step further. We're going to look at the converse, so the opposite of the hypotenuse theorem. So if the sum of the squares of the lengths of the two sides of a triangle are equal to the square length of the third side. So if you take A squared and add it to B squared and it equals C squared, then that is a right triangle. So pretty much saying what we just solved. But we're taking this and looking into Pythagorean Inequalities theorem. So what if they're not equal? That means different things. So if we say C is the longest length, that's our hypotenuse. And if C squared is greater than the sum of our two legs squared added together, then that is going to be an obtuse triangle. So if A squared plus B squared, if that is going to be smaller than our C squared, then it's an obtuse. The C squared would be larger. Now if C squared is less than our A squared plus B squared, then that is going to be an acute triangle. It's going to make a little more sense when we do some problems. So we are given three side lengths, and we need to determine if it's a triangle, and then to classify it as acute, obtuse, or right. So determine if it's a triangle. We're going to take two sides and add them together, and that length has to be larger than the third side. So let's do 8 plus 11. Is that going to be greater than 13? 8 plus 11 is 19. 19 is larger than 13, so that works. Now let's take two other sides. We have to try all possible combinations. So 11 plus 13, is that going to be greater than 8? Yes. What about 13 plus 8? Is that greater than 11? Yes. So this is a triangle. So now we need to know what is going to be classified. So let's go on and classify. We're going to take the longest length out of 8, 11, and 13. We're going to square it. And then that has to be either equal, greater than, or less. And we don't know the symbol yet. And then we're going to take our two legs, so 8 squared, and add it to 11 squared. 8 squared is 64. And then 11 squared is 121. And then let's do 13 squared. 169. So now, still don't know the symbol. What is 64 plus 121? That is 185. So we have 169. And then we need to figure out the inequality to 185. Which number is larger? 185. So it's going to be less than. So if our C, our hypotenuse, is going to be smaller than the sum, that's going to mean it's acute. Let's look at the next one. We need to determine if 7, 12, and 16 lengths are a triangle. So we're going to take 7, add it to 12, and that needs to be greater than 16. 7 plus 12 is 19, that is greater than 16. Now let's do 12 and 16. Is that going to be greater than 7? Yes. And then lastly, 16 plus 7, is that greater than 12? Yes. So this is a triangle. So now we need to know what kind of triangle. Let's take our larger side, 16, and square it. We don't know what inequality symbol is yet. And then we have 7 squared plus 12 squared. 7 squared is 49. 12 squared is 144. And then 16 squared is 256. We're going to add 49 plus 144. We get 193. So we are going to compare 256 to 193. Which number is larger? 256. So our inequality is greater than, so then that is going to be an obtuse triangle. Okay, let's look at the next one. We have 11, 18, and 34. So let's see if this is a triangle. We take 11 and add 18 to it. Is that going to be greater than 34? 11 plus 18 is 29, and 29 is not greater than 34. So it is not a triangle. If it's not a triangle, we cannot classify it. So then we are finished with that problem. Let's look at the next. 9 plus 11, that has to be greater than our third length of 15. And it is. Then we're going to take 11 and 15 and see if it's larger than 9. And it is. Lastly, 15 and 9, is that larger than 11? Yes, so this is a triangle. So now let's classify it. Take the largest side, 15, and square it. We're going to compare that to 9 squared plus 11 squared. 15 squared is 225. 9 squared is 81. And 11 squared is 121. So we're going to add 81 plus 121. We get 202. And we're going to compare that to 225. 225 is larger than 202, so that is going to be greater than. So this is an obtuse triangle. So that is your lesson today on the Pythagorean theorem. Please reach out if you have any questions.